up, young programmers? It's Coding Boy 56 back at it with another video. Today we're going to learn how to square up. So, hey guys, let's jump into the line squaring program. So we're gonna grab out 8 different variables for this, not very difficult. And we're gonna make this a customizable my block. And so because it's a my block, we're gonna have parameters for it. And each of those parameters are gonna be plugged into the variables. So we have 8 different parameters and 8 different variables. So one of those variables is gonna be speed. That's going to be the speed that we want the robot to be going at its average when it's exactly at the black and white. Well, at least one of the sensors, because making a line squaring program requires 2 sensors instead of 1, like you would need for a line follower. So that would obviously be 0, because you don't want to be moving if you're exactly where you need to be. Another one of those is KP. Since this is an advanced type of video, we're gonna be using a KP value. We're also gonna be using low, and this is what we'll be using to detect the line initially. Anymore, I'm trying to remember what else we need. Yep, starting speed is what we're gonna need. So the speed that the robot will be driving at before it hits the black line. We'll need that. We'll need the left light sensor port. Make a copy of that. We'll need the right light sensor port. And I'm missing out on one right now, so I'll make one. Or never mind, I actually have it. It's called duration. So the longer this this code is running, the program is running, the more accurate of a line squaring you're gonna get. That's just how this program works. So we'll start off by making a gross adjustment stage. I'll keep a little comment here just to mark that. And for this video, since line squaring is a very long process, if you want it to be very accurate, I'll make a part 2 to this. I'll make a sequel. I don't want to make this video too long, but today I'll cover the gross adjustment stage, and in a second video later on I'll cover the fine adjustment stage. Now we're gonna want to mark this for debugging purposes, and I can do that with the LED light, or you can use a sound if you like, just to mark that it's reached the stage. I'll turn the LED light on at this orange color, and then I'll turn on the pulse true. That's simple enough. Yeah, and then now what we're gonna do is have a switch. Yep, right, got it. Okay. And the switch is gonna be set to the color sensor, compare, reflected light intensity. I'll keep this in wire just for customizable reasons, so I can get one of these later. Read numeric, these left light sensor ports, so I can plug in. Now the way the program works is that you can almost imagine as if the left light sensor port is connected to the left motor, and the right light sensor port is connected to the right motor. Now your average. Sorry, my voice is a little hoarse. It's going right now. Oh, I forgot to grab out an average, it seems. Yeah, I'll grab one of those. Copy paste it there and set it to read numeric. And it's going to be set to compare type 5 less than or equal to. So if the robot senses the black line, in other words, if it's, or I'll keep it to low. Low is probably better for this. If it's less than or equal to low, it should stop the motor. That's what we'll set it to, the left motor. Now for my robot, the left motor is B, so we'll leave it at that. Oh, my bad. I forgot to turn on the motors on in the first place. I'll do that right now to keep it to on. And we'll set them both to starting speed. Now we're gonna want to wait until color sensor senses reflected light intensity that's greater than or equal to, again, less than low. And set it to wired. And this time it's going to be set to the right light sensor port. And that's because we want to stop each of the right and left motors we want them to stop and start where they need to. Once we stop the left motor, we want the right motor to keep on continuing until it's seen its target. Now once it's wait for that, then we can grab one of these stop for large motors and plug it in for your right motor, which happens to be C for my bot. So now all this chunk of code is written is that it's initialized the variables at the beginning, of course. It's sending off a signal for debugging here with the orange light. And now for the loop part, it's checking if the left light sensor port has seen less than or equal to the low light value. And if it has, then it will turn off the left motor, and it'll keep the right motor going until it reads less than the low value with the right light sensor, and turn that one off here. Now, we haven't programmed for this case, so let's get to that right now. You can actually grab this loop, this chunk of code, and then put it right here. You can just switch out the ports later on. I'll zoom out a little bit. Hopefully that doesn't decrease the resolution too much. You guys can still see. Just for a little more convenience. So if it hasn't detected anything with the left light sensor yet, we want to check the right light sensor. So I'll do that. Switch that out here. And then I'll switch this out to motor C. Switch this out to the left light sensor. And this one out to B. So now, if it hasn't sensed anything with the left light sensor, it's simply checking if the right light sensor has detected the black line, and if it has, it's sent to stop the right motor, and it's waiting until it sees low again with the left light sensor to check the other one, and then stops that respective motor. And if it hasn't detected anything, it of course does nothing, and the loop repeats, so on. And that's pretty much it for the major section for the line squaring. This is the gross adjustment stage. Again, I'll be covering the fine adjustment stage in next week's video. If you like that long, boring, and probably painful to watch video, remember to hit the thumbs up button. And fun fact, my mom is 8% of my subscribers, and you want to be cool like my mom, right? So hit that subscribe button, and don't forget to ring the notification bell. Go to the end card.